Hello, this is John from caveofprogramming.com, and in this tutorial we're going to look at creating or writing files in Perl, and we're also going to look at replacing text, so doing basically a find replace on some text using regular expressions. So in the last tutorial we looked at an example of reading a file and of checking each line to see if it matched a certain simple regular expression. And I'm going to continue working with this in this tutorial, but first we're going to look at how to actually create files. And in the last tutorial we created this program that just looks for the word egg surrounded by spaces. So I'll keep that there for the moment, and I've created a new file for this tutorial, and I've just got this skeleton typed out of a basic, what I consider to be a basic Perl program, and we've just got use strict, use warnings. We've turned off output buffering so that we can see stuff that we print immediately for sure. We've got a main subroutine, and we're calling the main subroutine here just to give it a bit of structure and make it easier to read. So let's declare a name for our output file, and I'm going to say my dollar because it's a scalar, a single value, and I'll call this let's call it output. We could call it anything, but I'll call it output, and I'll set it equal to the output file name. And you could specify complete file paths for your output file name, just as for an input file. Like in Windows, it could be C:\/ such and such, or you can just give it a relative name, in which case it's going to be output in the working directory of your program. So let's do the latter in this case, and I'm just going to call this output.txt. Now to open that file, again I use the open subroutine, the built-in subroutine called open, and I say open, and let's use round brackets here, although they are optional, and I'll give the file handle the name output in uppercase letters, and it doesn't matter that it's output. I could call it anything. I could call it fish. And I'm not even sure if it matters that it's in uppercase letters. Maybe it does, I don't know. But that's the convention. So give it some kind of name, this file handle, and put it in uppercase letters. And I'll call this output, and then comma. And the second argument to open is the output file name, which is $output, lowercase. And then I'll say or die, and in quotes I'll say can't create $output, so that we have a nice message including the name of the file that we failed to create. Now if the program doesn't die, I'll then continue and I'll say close output, like this. So I'm calling the close subroutine and passing it the output file handle, and let's just save that. And we've got an error here. Oh, and that's because I misspelled output. And actually this is really good because this enables me to demonstrate the purpose of use strict. If I didn't have use strict in here, then I would not have had to write my $output. And then when I misspelled output here, I put output, and here I've got output. And if it hadn't been for my and use strict, I would never have realized that there was an error here. Well, I would have realized eventually, but maybe not so quickly. And so that's why it's so useful. By forcing me to declare this variable when I first use it with my, I then know if I've spelt it differently later on. And that's the purpose of use strict. It forces you to use my here. So let's change this and put output, which is great. And now I'm going to run this. And what we see is that it says it can't create output.txt. Let's get rid of this line number because I'm going to pretend that I'm writing a nice program for an end user. So in die here, I'm just going to put at the end \n, like that. And then that somehow, I don't know why, but somehow it stops that extra output about the line number, which is not appropriate in a program for an end user. Now the reason we can't create output.txt is because to create a output file, you've got to have in the file name as the first character a kind of right angle bracket like this. That turns it into a, or that kind of tells Perl that you want to create this file. So if I run this now the error message is gone and it can and has created the file. Let's just right click the project here and go to refresh, and now we can actually see output.txt, and if I double click that we see that it's empty at the moment. Now you may have like some really complicated name in here, and I often think that it's kind of unpleasant to mix up this special character with the actual name of a file. Oops, there we go. So what I like to do is I leave it like that, so that's just the name of the file there, and then when I use it here I can concatenate that character to it. So I have a little string here in single quotes which is nothing but that character, and to concatenate that to this string $output I use the dot character. In a lot of languages, if you want to concatenate two strings, put them together to make one big string, you use a plus sign, but in Perl it's dot. So this puts that character there and has the same effect as if I wrote it exactly here where the cursor is right there. So now that should work, and that's good. And you only need that when you're creating a file. Don't use it on an input file because then it won't work. I'm not really sure why there's a little bit of an error there, but I won't worry about that because it is, yeah, it was just Eclipse being funny. Okay, now let's write some stuff to that file, and to do that I put print, and if I were to put print hello, and let's have a new line as well while we're at it, and semicolon. So this will print hello followed by a new line character, and if I just run that, the program is creating my file and it's printing hello on the console. But if I put output here, print will print to output. Now the confusing thing is that this is not a parameter to print. It looks like it is, but it isn't. It's some kind of, well, in a way it sort of is, but it's some kind of special thing that tells print to print to this file. So the upshot is you don't have a comma there. You just say print output and then the stuff you want to print. And I'm saying output just because that's the file handle here. And by default, print prints to standard out, which is a standard std out, which is a standard kind of handle that would put stuff to the console. But here I'm telling it, use my file handle that I created here and that I've called output. So if I run that, we don't see any output in the console. But if I now go to output.txt, we see it's got hello in it. Now, I thought it would be interesting to combine this with reading the input file, because then what we can do is we can read the input file line by line. We can do a find and replace on each line to replace egg with something else, let's say, and then we can write the edited version to the output file, and this is a very common task in Perl, and you could even combine it with the stuff that we looked at in an earlier tutorial for processing lots of files at the same time. So let's go ahead and do that. I'm going to go to this file that I created in the last tutorial for reading a file. I'm just going to copy all this stuff, Control C, and I'm going to paste it in here. And now what I want to do is I want to first open my input file, and then I want to open my output file. So let's copy these two lines and paste them in here. And we could have some comments in, which actually I'm going to go back and put in after this tutorial to save time. So we define the input file and open it. And we could even call this input. And in fact, let's do that. Let's change that to input. So we open an input file, then we open the output file. And later on we need to say close the input file and close output. So we always remember to close the files, although Perl will do it automatically, but it's just kind of good practice to do that and to remember to do it. In some situations it may make a difference. Let's save this, and I'll come back to this error shortly because I'm not really sure why it's there just in a minute. So we're opening the input files, the input file and the output file, and we're closing the input and output, and I'm iterating through the input file. And let's get rid of this print to the output and I think this all looks good. Let's save that, and now let's check what I've done wrong here. So I'll hover over this, and in fact it's not even giving me the error, which is kind of annoying. So I've said open input $input or die input file not found. That's the problem, that I don't know why it's not giving me the actual error if I hover over this error. That's quite annoying, but it's just because this file doesn't exist. And again, because I've got use strict declared, any variable that I use has to have been declared with my, and if I didn't have use strict, this probably wouldn't give me an error. If I delete it, there's no error. There's just actually a warning actually, but it would let me run the script even though it doesn't do what I want it to do. So let's change this to $input. So it says input file $input not found if it can't open the input file. Now we're getting there. Now let's print all of the lines to output to start with. So as in the last tutorial, I'm reading the input line by line. I'm checking to see if it contains the word egg surrounded by spaces, and then if it does, I'm printing it on the console, but I'll now print it to output instead. So I'll say print output $line and I'll run it. And now if I go to the output.txt, we've got a load of lines containing the word egg. One thing that's not very satisfactory about this is that won't catch instances of egg where there's a full stop here. It's only looking for egg with spaces either side. And to do that, we can use a special control sequence within the regular expression, and we'll be seeing more of these as these tutorials progress. But I can use \b, and what \b is, and I'll put one of those either side, is it's a word boundary, so it doesn't match any characters in itself. It just makes sure that it's matching egg with a boundary, a word boundary either side. And a word boundary would be basically a space, or I think a hyphen or a full stop or anything like that. It's basically looking for egg without another word immediately joined on either side of it. And if I run that now, then we are that's weird. I could have sworn I told this to write to, oh, I've gone back to my original file. Yeah, so I meant to put this in the edited version, not the old version. So I'm just going to copy that. I'm going to leave this version as it is, because I'm going to put this code on caveofprogramming.com. Let me go to my edited version here, my new version for this tutorial, paste that in. So we're looking for egg as a freestanding word, and we put /b in to match the boundaries of the start and end of egg as a separate word. And I run that, and what this now does is it's printing to output.txt, and it's printing anything with egg in it. And you can see that I've, for example, here I've matched egg with a full stop over it, because Perl is correctly represented, correctly seen, correctly understood that this is the end of a word. It's a word boundary, and this is the start of a word. So we're correctly matching any occurrence of the word egg there, as far as I can see. One last thing for this tutorial is I'm going to now replace egg with something else. Let's replace it with nut, or it could be something of a different length, but it doesn't matter. Let's try nut. So to do a replace, what I need to do is I need to do, well, I'll leave that in, I think, and after that, or yeah, what I could do is, like, if it contains the word egg, then you know, I really can't decide here. In fact, I know what, let's leave this egg stuff alone, because I'd like to leave that as an example. Let's leave that alone, but what I'll do is I'll pick a different word, like maybe something, and I'll replace that, because that would make more sense. Okay, so we've got, I'm looking for any words that occur like quite often, but probably there aren't any good ones. Maybe in, well, I could spend a long time looking really. Let's replace you. Let's replace you with uppercase U. let's say that'll do. Okay, so I want to, for every word, for every line here, I want to replace all the occurrences of U in lowercase with uppercase U, let's say. So to do that, I use a kind of regular expression. And a normal regular expression, if I wanted to search for the word U, I would say a forward slash here, the word U, like this, and another forward slash, and a semicolon. And that is searching for U. And, well, actually, I haven't told it what to search in, so I also would have to say $line equals matches, or equals tilde, if you like. And there should be no quote there. So this would search for U in $line. And this wouldn't actually do anything in itself, but if I put an if statement around that, exactly like we've got here, then we could say if the line matches U. But what I want to do is I want to replace U with something else. And to do that, I just have to say, I type at the end here, before the semicolon, I type the thing I want to replace it with. And let's replace it with uppercase U, like that. And then another slash, like that. And to tell Perl that this is a replacement, before the opening slash I press S. Now I feel you're probably thinking, what the hell is this? And feeling completely lost. And that's how I felt when I first saw this, believe me. It seems counterintuitive, but there are only a certain number of these weird structures in Perl, and once you've used each one a handful of times, you do start to feel comfortable with it. So although this looks like nothing on earth when you first see it, after a while it does make sense to you. Another thing I'm going to do is put a character here after the last slash and before the semicolon. And I'm going to put, there's a bunch of things I could put here. If I put I, that makes the match case insensitive. And if I put G, which stands for global, that would replace all occurrences of U, whereas without the G it will just replace the first one. And I'm sure we're going to see examples of this again. So don't stress, and my advice is don't stress, don't feel you've got to memorize this. Just use it. If you think that you're going to need this in future and you actually want to learn it, my advice is type it out a few different times in different little programs and get used to it. So now this is searching for egg and outputting the line only if egg is in it. And this is changing U for uppercase U. So we should be able to see if this has worked here, because we can look at the lines that contain egg that have been printed to output.txt. But of course the way I've written it, this is replacing U in every line. It's just that we're only printing then lines if they have egg in them, and actually that's quite inefficient. So let's just take this maybe and move it down here, because if we replace the line and then don't actually do anything with the line, then that doesn't accomplish anything. And just the fact that we type this isn't going to change the input file. We can only change the output file. There are ways in Perl of doing an in-place edit where you can change the input file, but like this, all we're doing is reading that input file, and what we do to each line will make no difference to the input file. The only reason it's going to have an effect here is because we're then taking this line that this variable refers to and printing it to the output file. So we're changing the output file. And let's just run that. And now look at the output.txt, and you can see that there's only one of them, I think, but where we've got U, we've now got uppercase U. And in fact there's a couple of hens here I've just noticed. So let's try hen, and let's go here and let's take hen there and replace it with dinosaur just for kicks, and click run. And now if I look at the output, we can see that we've got a lot of dinosaurs in here, more than I expected really. And this would actually replace hen even if it was part of a word. And if we just want to match hen by itself, then again we would need to put the word boundary stuff in like this, because here I don't know if there are any examples here, but we would get dinosaur even in something like then, the word then, which contains the word hen. But I'll leave that for now, since that's quite enough. And I'll put this code on caveofprogramming.com, and I'll put some comments in it as well, I promise. So until next time, happy coding.